Viewers, welcome to Senior Teleclass on Tech TV. And today, we are still doing our introduction to chemistry. We are in the third lesson. We are going to discuss symbols and formulae. And our learning objectives, by the end of the lesson, you would be able to identify symbols for different elements. Secondly, you will be able to write correct symbols and formulae for chemical substances. And thirdly, you will be able to determine the atomicity of substances. And what are symbols? A symbol is a shorthand form of writing the name of an element. And how do we write symbols for elements? We use the initial letter or the initial letter and one other letter in the English or Latin names of elements they are used. And always the first letter is capital, but the other letters are small letters. Let's look at, for example, if I have these substances, carbon, chlorine, cobalt, chromium, cerium, cesium. You see, all these elements begin with capital C or letter C. So if you are representing C for these elements, there will be confusion. And we use C for carbon. When we look at chromium and chlorine, we have the first two letters are the same. So if you are to represent them by CH, it will be a problem. And so we have Cl for chlorine, Cr for chromium. And the same applies to other. So either we use the first letter or the first letter and one other letter. Now, whenever we are using the first letter, it is always capital. But if we are using other letter in addition, the second letter that we are representing should be a smaller letter. Sometimes some people write chlorine as Cl. It is wrong, because the second letter should not be a capital letter. And if you also write Cl like this and C is small, it is also wrong. The C should be capital and the L should be small. So let us look at examples of these symbols. If you look at the element and its symbol, we have hydrogen, which is represented by H. We have oxygen, represented by O. We have carbon, represented by C, as I mentioned. We have phosphorus, represented by P. We have nitrogen, N. And we have boron, B. We have sulfur, S. All these elements, you see that they are represented by single letters, and they are all the initial letters of their names, English names. There are others which we represent by two letters. Let's look at examples of such elements. We have aluminium, represented by Al. You see that A is capital, but the L is small. Then we also have magnesium, where we have M and G. We are not using M and A, we are using M and G. And you know, as usual, J is small, M is capital. We have chlorine, Cl, and C is capital, but the L is small. We have radon, which is Rn. We have cesium, Cs. We have calcium, which is Ca. So these are the substances whose English name are being used. If you take substance like copper, and we have the name, English name, copper, we don't use C, we don't use CO neither, but we use CU. But if you look at the English name, you see that there is no U in the name of copper. But how do we obtain the Cu? Let's look at examples of such. We have the English name, sodium, for example. The Latin name is natrium. And you see the symbol is Na, where we are taking it from the Latin name, the first two letters. We have another element, potassium. From kalium being the Latin name, we are using the first letter K. We have silver, argentum, we are using Ag. We have gold, aurum, we are using Au. We have iron, ferrum, we are using Fe. And we have lead, plumbum, we are using Pb. We have copper, as I mentioned, the name is cuprum from the Latin, and we are using the Cu. We have mercury, there is no H in the English name, but we have hydrogen. So the name, the symbol is obtained from. So as we mentioned, symbols are obtained from the first letter or the first letter and one other letter, either from the English name or from the Latin name of the element. Students, let's move to formulae. How do we obtain formulae, or what is formulae at all? When we talk about formulae, chemical formulae, because we are dealing with chemical substances. When we talk about chemical formulae, we use it to identify compounds. Every compound has a formula representing it, or a formula representing it. And chemical formulae, they show the kind and the number of atoms that are present in the compound. And when we are writing formulae, we combine elements and we take into consideration the combining capacity of the various elements. And this combining capacity, we call it as valency. If you see valencies, that is the combining capacity of the elements. And so we want to look at how do we write formulae for compounds. When we are giving sodium chloride, let's see, we have Na plus and Cl minus. The Na is sodium, Cl is chlorine. Na has combining capacity of 1 plus 1. Cl has combining capacity of minus 1. But when we are to write the formula or formula for sodium chloride, sodium will bring 1 and chlorine also bring 1. And then because of neutrality, we interchange the combining capacities so that sodium will take 1, chlorine will take 1. But because we don't write 1, 1, we write the formula for sodium chloride as NaCl. And that is the formula for sodium chloride. So you see that the N is capital, the A is small. C is capital, L is small. If I write it like NaCl, it is wrong because you see that the C is very small. But the C, in the first letter for the symbol for chlorine should be capital. So that is how we write the formula for sodium chloride. Let's take aluminium combining with oxygen. We have aluminium bringing plus 3, oxygen minus 2. So the combining capacity of aluminium is 3. And the combining capacity of oxygen is 2. So when we have these two atoms or these two elements combining, then we interchange their combining capacities. So the aluminium will take 2 and the oxygen will take 3. So that is formula for aluminium oxide. So you see that the compound is neutral because aluminum with a charge of +3, we have 2 giving us +6, and oxygen with a charge of -2, we have 3 giving us -6. So +6 -6 gives us a neutral atom, or the charge 0. So the formula for aluminum oxide is Al2O3. So let's look at other examples. We have magnesium combining with chlorine. Magnesium has a charge of +2, chlorine a charge of -1. So the combining capacity of magnesium is 2. The combining capacity, which is the valency of chlorine, is 1. Now, when we interchange them, you see that the magnesium would take 1 and the chlorine would take 2. But because we don't write the 1, we have the formula for magnesium chloride as MgCl2. So whenever magnesium combines with chlorine, we have the formula as MgCl2. And the compound is neutral because magnesium we have 1 charge of +2. Chlorine we have 2. Each one has -1. So the total of -2 +2 -2 will give us 0. Now let's look at a formula formed between magnesium 2+ and oxygen 2-. And again, the combining capacity of magnesium is 2. Combining capacity of oxygen is 2. So when we interchange them, we have Mg2O2. But 2 is common. And so as 1 they cancel out. So that the formula for magnesium oxide is MgO, not Mg2O2. So if you see sodium chloride, it is NaCl, magnesium chloride is MgO. You think that they have the same charges? No. Because of +2 and -2, so we are having a neutral compound. And that is how we write formulae for this. Let's look at other example. Let's take this time group of atoms, SO4 2-. The SO4 2-, the whole species has a charge of -2, and sodium has a charge of +1. So the combining capacity of sodium as usual is 1, and the combining capacity of the group SO4 is 2. Now, when we interchange the combining capacities of the two species, we have sodium taking the 2, and the whole SO4 would take 1. But because we don't write the 1, we remove the bracket, and then we write Na2SO4 as Na2SO4 as the formula for sodium tetraoxosulfate 6. I mentioned sodium tetraoxosulfate 6. When we come to nomenclature, naming of compound, you understand why it is sodium tetraoxosulfate 6. Let's take aluminium combining with sulfate. Aluminium is coming with +3, so the combining capacity of aluminium is 3. And combining capacity of the sulfate is 2. So this time when we interchange, aluminium will have the 2, and SO4 2- will have the 3. So you see that this time I'm not removing the bracket because 3 and 2 are not the same. So when we meet compound like this, we will know the charge or the combining capacity of each of the species that join together to form the compound. And that is the formula for aluminium tetraoxosulfate 6. So let's go to other species and see. When we have calcium 2+ and sulfate or tetrasulfate 6, 2 minus. We see that calcium has a charge of +2. Tetrasulfate 6 has a charge of -2. So the combining capacity of calcium is 2. Combining capacity of SO4 is also 2. When we interchange, we have calcium taking the 2 and the group also taking 2. And you see that 2 and 2, they are common. So this time we remove the bracket and we have the formula CaSO4. And that gives us the formula for calcium tetraoxosulfate 6. And so that is the how we write formulae for compounds. So students, you have seen when the charges are 1, 1, or 1 and 2, 2 and 1, for elements 2 and 3, then when you have group of atoms, we combine the whole group, combining with a certain number. So when we see that the numbers are the same, we remove. But when it is also 1, we remove. But if it is not 1, as we saw for aluminium tetrasulfate 6, aluminium with 3, sulfate with 2, we don't remove the charge from it. Let's look at another substances. This time, both ions are group of atoms, not single atoms as we saw. So we are going to look at such species when we have NH4 with a charge of +1, NO3 with a charge of -1. Then the whole group NH4 is coming with 1. NO3 is also coming with 1. When we interchange their combining capacities, we have NH4 with a charge of 1 combining, NO3 also 1. And we see 1, 1. So we remove the bracket, and to obtain the final formula for ammonium triosonitrate 5 as NH4 NO3. So because of 1, 1, we have removed the bracket from the two species that combine. Now let's look at another group of atoms combining, and we see that NH4 plus is combining with CO3 2 minus. As usual, NH4 plus will bring a charge of 1, so their combining capacity is 1. CO3 2 minus, the combining capacity is 2. When we interchange their combining capacities, we see that NH4 will take 2 and CO3 will take 1, but we don't write the 1. So we remove the bracket from CO3 and we obtain the formula NH4 to CO3. So that gives us the formula for ammonium triosocarbonate 4 or ammonium carbonate. So that is how we write formulae for compounds. So anytime we are given ions to write formulae, we have to consider the charges, which will be the combining capacities of the substances or the species. And when they combine, if we see that it is 1, we don't write the 1, we remove the bracket. If it is not 1, we maintain it. So we are going to look at some so that you try your hands on them for us. So now when we combine these elements or these species, we have something we call atomicity. When we talk about atomicity, what do we mean? It tells us the number of atoms that join together to form the compound or the substance or the species. So let's look at the atomicity as we define it. We said the number of atoms present in one molecule of a substance is called atomicity. Let's take example, hydrogen gas. It denotes we have the formula as H2. The 2 is representing the number of hydrogen atoms. So H2 denotes a molecule of hydrogen gas, and it contains 2 atoms of hydrogen. Let's take another substance, H2SO4, which is tetraoxosulfate 6 acid or sulfuric acid. This one we have 2, we have 4. What are they representing? This H2SO4 denotes a molecule of sulfuric acid or tetraoxosulfate 6 acid. It contains 2 hydrogen atoms, so we see H2 there. It contains 1 sulfur atom, so there is no number attached to the sulfur. And it contains 4 oxygen atoms, so we see 4 there. That is what we call as atomicity. So when you are given any substance and then you are asked to give us the atomicity, I believe or I hope you'll be able to give us the atomicity. So let's look at the examples. We have the noble gases or the inert gases or the rare gases. Their names. Why do we have noble? We have rare, we have inert. Noble, we know that when somebody is noble, he is a person who does not want to mingle himself or herself with others. So these substances don't want to combine with others. And rare, they are not common. We don't see them. They are inactive, so we say they are inert. So the 3 names reflect them. And we see that helium, neon, argon, krypton, xenon, though all of them have 2 letters, but there is no number attached. So what do we say? We say that these elements, they have atomicity of 1. So we say that they are monoatomic species. The atomicity is 1, so we say they are monoatomic species. Let's look at another example. When a molecule contains 2 atoms, we say the element or the molecule has atomicity of 2, or it is a diatomic species. Many we say they are diatomic species. Let's look at examples. If you take H2, hydrogen gas, we see the 2 there. If you take N2, we have 2. O2, we have 2. Let's take NOACl, NaCl, CO. Unlike the first 3, which have 2, 2, 2, we have NO. N is 1, O is 1, though we don't write. So the 2 will give us 2. So the atomicity of that substance is 2. The same applies to ACl. The same applies to NaCl and CO. So such compounds, we say they are diatomic species. We have another one which have atomicity of 3. And such species are termed as triatomic species. So when they are made up of 3 atoms, we say they are triatomic species. Example, let's take ozone. We see O3, O3. That means 3 oxygen atoms. If you take CO2, we have 1 carbon atom, you have 2 oxygen atoms. 1 plus 2 will give us 3. We have carbon 1, oxygen we have 2. If you come to water, H2O, we have hydrogen, 2 atoms, but oxygen is 1. So 2 plus 1 gives us 3. Let's take sodium hydroxide. This time we have 3 different elements. We have Na representing sodium, we have O representing oxygen, we have H representing hydrogen. Each one we have 1 atom, 1 atom, 1 atom. So 1 plus 1 plus 1, 3. And it is triatomic species. So it is not just 1 element. Ozone is 1 element, oxygen. But CO2, H2O, they are made up of 2 elements. But one is 1, the other is 2. When we take NaOH, made up of 3 elements, 1, 1, 1. So it is a triatomic atomic substance. So when we have to give triatomic species, either we give a single element with 3 atoms, or 2 elements, 1 is 2, 1 is 1, or we give one substance which contains 3 elements, 1, 1, 1. That is triatomic. We take the 4th example where we have 4 atoms, and the atomicity of that compound or substance is 4. When we say it is tetra atomic species. Let's take example NH3. We have 1 nitrogen atom and we have 3 hydrogen atoms. So 1 plus 3 will give us 4. The same applies to SO3. We have 1 sulfur, 3 oxygen. But when we take phosphorus, we have 4 atoms of phosphorus, and that atomicity of the phosphorus is 4. So such species are termed as tetraatomic species. Generally, any substance that contains many atoms, we can call it as polyatomic species. Whether it is 2, whether it is 4, it is 5, 10. Let's look at example. Zinc sulfate or zinc tetraoxosulfate 6. You see that we have 1 zinc atom, we have 1 sulfur atom, we have 4. And if you look at, we have 6 of them. So we can say it is a polyatomic species. Let's take magnesium sulfate heptahydrate. We have the magnesium, the sulfur, the oxygen. Even there we have 6 atoms. Then we come to the water. We have 7 affecting the water. Phosphorus, P4, NH3, all these have many atoms, and we call them as polyatomic species. So students, we have seen how we write formulae for substances and how we classify them. We said if it contains 1 atom, it is monoatomic or atomicity is 1. If it contains 2, atomicity is 2 or diatomic species. If it contains 3, it is triatomic, 4, tetraatomic. And don't forget, di, tri, tetra, it can be 1 element, it can be 2, it can be 3, it can be even 4. So depending on the number of atoms present, we call it as atomicity. So let's look at this question, and then I'll give you some just 1 minute to give me the answer. And the question 1 is, write formulae for compound formed from the following species. We have Pb2 plus and O2 minus. Fe3 plus and SO4 2 minus. Cu2 plus and OH minus. IV, Na plus and HCO3 minus. So you take, it's supposed to be HCO3. So put the 3 there. Put the 3 there so that you can give me the formula. So it will be Na plus and HCO3 minus. So that is for the IV. So let's, so I'm giving you 1 minute to give me the answer. I hope you are trying to get correct answers. When I come to check, I expect you to score 4 out of 4 because we have taken time going through. I believe you have finished. So let's look at the answers that you provided and mark it yourself. So you see, we have PBO. If we go, we see that Pb2 plus O2 minus 2, and therefore we don't write, so we have Pb. If you see Fe was plus 3, SO4 minus 2. So you see that when you interchange, you obtain Fe2 into bracket SO4 3 minus. If you look at the 3, we have Cu into bracket OH minus. If you go back, you see that Cu has a charge of +2, OH minus 1. So when you interchange, you get the correct answer, which is CuOH. And IV, we have Na with a plus, HCO3 with that. So when you put into bracket, because of 1, 1, you obtain, you see that we have Na plus, HCO3 minus. When you interchange, you have 1, 1, and that gives you. So I hope that you have done your answer correctly. So let us look at another question. Mention one element which is, so I want you to write one element which is monoatomic, II diatomic, I tetratomic. Don't forget, I say element. I did not mention compound. So hurry up to give me the answer. You are just mention the formula or the element. Mention the element. So mark it yourself. We have helium, neon, argon, and so on. They all have monoatomic, or they are monoatomic. The second one, we see O2, H2, Cl2. They are diatomic elements. And then we have phosphorus, which is P4 tetra atomic. So I hope you have also scored 3 on 3. So let's write this assignment when we go home. We try, so next time when we come, you show what you have done for me. Write formally for compounds or compounds formed from the following species. We have Pb2 plus, O2 minus. Then we have Fe3 plus, OH, NH4 plus, and SO4. These are group of atoms. Then we have V5 plus and O2 minus, Mg2 plus and IO4 minus. I hope you will do justice to them. And next time when we meet, we will start. We have talked about two things, symbols and then formulae of compounds. And you know how symbols are represented. And you know how formulae are written. And you know the atomicity of substances. These are things that we have discussed. So go home, go and study, go through, and then do the assignment. When we come, we will look through. Bye-bye.